Hello guys, I hope you are doing well in this COVID-19 situation, and this video is basically on a how to size the hydraulic power unit. So before starting this video, I just want to tell you you can download the spreadsheet. This is the spreadsheet we have here, and you can use it for your own purpose. The link of downloading this spreadsheet is available on the description area of this video. But before downloading, please subscribe my channel and get regular updates on the new videos and new spreadsheet available on YouTube channel. So let's begin. Before starting anything, you should have some basic details about your actuator. That's a linear actuator, and you should know about your working pressure of the system. So if you have some basic details, then you can start the calculation. You can get very good data from this spreadsheet. This spreadsheet has all the units in imperial system, so it's basically for all the North American and states guys, and they can use it a very easy way. So in this spreadsheet, the yellow cells represent some data you have to enter, and the gray cells will give you the answers. In this spreadsheet, I'm just taking one example of, let's say, the bore diameter of my linear actuator. That's a hydraulic cylinder. It's a bore diameter having 10 each, and the rod diameter, let's say, it's 5 inch, and the stroke size, let's say, it's 11-inch stroke size, and I have only one piece of this actuator in my hydraulic power unit. But you can enter a bunch of actuators underneath, and you can get the flow number of like how much quantity of, or how much GPM of flow you need to operate this all cylinder together, and by sequentially as well. So you can enter all the details over here, and you can get your flow velocity and volume required to fill that actuator, everything in a single shot. So I just enter the bore diameter, and let's say this is a big cylinder. So T opening and T closing. What is T opening is time required to extend the actual actuator, and T closing is time required to retract the actuator. So in some cases it's always it's same, but to show you the different uh, facilities available in this spreadsheet, so I'm just entering different numbers over here, and you can easily get the correct numbers from this spreadsheet. So let's say the opening time or the extension time of the cylinder is 30 seconds, and retraction time is 45 seconds. And by doing this, the velocity of V opening is the extension velocity of actuator is 0.4 inch per second, and closing is, of course, the time is almost 15 seconds higher, so the velocity goes down. And the same way, the flow required to extend the cylinder is 7.5 GPM, and flow required to retract the cylinder is 1.2 GPM. So in this spreadsheet, you can use two cases parallel. Like, let's say, in normal case, the extension time is 30 and retraction is 45. But in emergency case, it is the case where there is a power outage or any other emergency condition, then you can set the algorithm, or you can set it in your PLC if you have, and you can change the time of normal case to emergency case, let's say 10 seconds, and the retraction time is again also the 10 seconds. So this gives you the emergency time flow you need to supply to the actuator to fulfill this operation, and again velocity as well. So this is basically details of your flow and velocity. You need these details to calculate the pump size and motor size. So let's go underneath, and again the yellow cell, it's asked about the working pressure. So let's say the working pressure is 2000 psi in our case, and we have to determine here GPM. GPM will be on our uh, thinking base, or we have to enter this detail because in different cases, like different actuators work simultaneously, or some actuators work parallelly, or some actuator work in sequence condition. So we have to define which actuators are working together or parallel, and then we have to do the sum of that actuator required flow, and the higher number we have to enter in this cell. So basically we have to select the worst case, in which case we need the maximum amount of oil flow to run the operation. In our case we have only one actuator. I just named this actuator drain control valve, and in this case we need 7.5 GPM flow. That's the maximum flow we need to operate this actuator in the extension condition. Again, emergency condition, it's a different case. We are not fulfilling our emergency case by the pump. So, and this is not happen every day, so we are not spending money on emergency case. Like, we are not selecting higher size of pump and motor to just fulfill this condition only. So in normal case we need 7.5 GPM for the extension, so I'm entering a round figure, let's say 8 GPM. I'm considering 0.5 GPM in other losses, and I'm entering the maximum 8 GPM I need to get out from my pump to function this cylinder. Okay, so when I am entering 8 GPM in this cell, then it gives me the size of my pump in each cube. In general case, the pumps available in CC. CC is cubic inch volume. So in many OEMs, or almost all OEMs, they're bifurcating their pumps based on CC number. So this spreadsheet gives you the direct calculation of this CC value, and you can select your pump based on this. So when you enter 8 GPM, the CC value is 23.7. So again, almost all guys, you know that we have pumps available in standard cubic inch values. So we have to select the higher size of 23.7 of our preferred OEM. Of We have to check the data sheet of our pump we need, and we have to select something the next size from 23.7. Let's say we have 24 cc pump available, and our pump is gear pump. You can again select the different pumps, and by selecting different pumps it will change the volumetric efficiency of pump and the total efficiency of pump. But in our case we have gear pump, so I'm selecting gear pump, and gear pump values is, so these are the efficiency I have entered, but I forgot to make it the gray values. We don't need to enter these values anytime. When you select gear pump to vane pump, then the efficiency will change and the all values underneath will change again. But in my case it's gear pump, so 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 the selected pump CC will be 24. How this 24 come? I'm telling you again. Uh, for getting this value of pump CC, you have to go to preferred manufacturer, and you have to select a next higher size of pump CC available from 23.7. So I checked. I'm just assuming one number, that's 24. I'm not taking any name of OEM, but many OEMs having this 24 cc pump available in the gear pump section. So when you enter 24, this will be your pump CC. This will be the new detail that based on this detail all the other calculation will move forward. So this 24 cc pump at 2000 psi will give me the flow of 8.1 GPM. Here maybe you guys confused why I entered 8 GPM here and I'm now getting 8.1 GPM, because this calculation give me 8 GPM flow required to operate this cylinder. I just make it 7.5 to 8 as a round figure, and when I make it 8 GPM, this gives me the size of pump, that is 23.7 cc, but this size is not available. This is non-standard size. The next higher size of pump available is 24 cc, and if I'm selecting 24 cc, then I have output flow from my pump is 8.1. So my as of now my flow of pump is 8.1, and I have to do all the calculation based on this number. So how the flow from 7.5 to change it 8, and from 8 to 8.1? If you don't understand again, then you can ask me on comment section, but I hope you understand. So let's move forward and let's select the a motor. In the North America, generally the frequency is maybe sometimes 50 hertz or 60 hertz, but in most cases it's 50 hertz, let's say, and the frequency variation is plus or minus 5%, and the selected motor RPM is, let's say, 1100, or let's say 1100. Then the then then flow. Okay, so we have to select the correct size of motor as well. If I'm selecting 1100, then my maximum flow generated from the pump will be 6.1. You can see the figure right now. But when I'm entering 14.5 and just press enter, then the flow changes from 6.1 to 8.1. So I need to select the correct size of RPM of my motor, otherwise I'm getting less flow than my original requirement of 8 GPM over here. So if I'm going lesser than 1450 RPM, then my flow is going down from 8 GPM, and that is not good scenario. So I have to select the motor of having RPM 1450. If I'm entering 1450 here, then my desired and my available flow from pump is 8.1 GPM. My power is 11.80 HP, and I'm considering 10% more as per the ISO rule. So the desired power, or the power my motor should have, is 12.98. It's almost 13 HP. So I have to select motor having 13 HP rating with speed of 1450, and plus the change on frequency is plus or minus 5%. If you are lowering the change in frequency, let's say plus or minus 2%, then again the motor size will change as well. So change in frequency, or variation in frequency, will also impact the selection of motor. Be careful with this motor selection, and check one more time about the HP and the speed of your motor. I hope you understand the selection of motor, and let's move towards the sizing of accumulator. So for selecting accumulator, you should know some other basic details as well. So you should know about your minimum working pressure, and about the maximum operating pressure or maximum working pressure of your actuator, and and how much volume of nitrogen you need for charging that accumulator. In many cases, like small accumulators, they doesn't need nitrogen bottles available on the HPU. You can charge it once, and you can charge maybe after 1 month, or maybe after a couple of cycles, or maybe after your schedule, after one schedule maintenance period. But in our cases, I'm considering a constant flow of nitrogen uh, charging gas that is available in the HPU. So this calculation will give you the size of accumulator you need, and what is the effective volume coming out from accumulator to do the emergency operation, and what is the size of a nitrogen bottle you need. So let's come up and see our emergency case. In our emergency case, we mentioned like 10-second for retract and 10-second for extension. So in this case, we need a flow of 22.4 GPM, and to generate this much higher flow, we need a certain amount of size of accumulator. Again, the accumulator calculation will not give you the flow. The flow that accumulator can generate. You can get that detail from datasheet. No accumulator will generate a different size of flow, or accumulator selection will not done based on the flow requirement, but different series of accumulator having a standard flow, so you should check what is the maximum flow rating of your accumulator. But the most important thing we should check is the volume we need to operate the emergency cycle. So for our case we need 3. Again, I'm sorry, I just mentioned the wrong unit here. This is in gallon. So we need 3.7 gallon in bore side to operate our extension cycle in emergency case. So let's say our uh, our cylinder is retracted and we need to extend it in our emergency case, and then we need 3.7 gallon of oil to pour in the bore side to completely extend my actuator. So my volume requirement is 3.7 gallon, and I'm going down in this area. And this in this area again, you have to enter only yellow cells details only, and then you will get the all numbers ready with you. But before selecting accumulator, you should understand all the details, like which parameter is saying what, and how you can use this to select the accumulator. So let's say the minimum working pressure I mentioned is 2000 psi, and the maximum working pressure is, let's say, 3000, and the useful volume or total volume of accumulator available, let's say we are selecting 15 gallon accumulator in our case. So in this case, what is the volume available at V1? So V1 is basically volume available at the pressure P1. So P1 is 2000 minimum operating pressure, and at minimum operating pressure my available volume in accumulator is 12.02. And what is the volume at P2? So P2 is the maximum operating pressure for my accumulator, and V2 is 9 GP gallon, 9 gallon. Yes. So what is the actual volume coming out from accumulator? So actual volume is always the difference between V2 and V1. So V1 and V2 is saying me 3 gallons, and my requirement is 3.7 gallon. So I'm short of my volume. My requirement is 3.7 gallon. You can see at this area the volume required in the bore side is 3.7 gallon, and I'm having the differential volume between these two pressures is 3.02 gallon only. So this will create a shortage. Why this creates a shortage, and why we are getting this difference of volume to get the correct size of accumulator? So in our case, we have to increase the size of accumulator from 15 to 20, or maybe next higher size, let's say 20 gallon volume of accumulator. Then I'm getting the differential volume of 4 gallon, and that fulfills my requirement. But you can change this value by keeping the original size of accumulator from 15 to changing the maximum operating pressure. Here I'm telling you, this number is not random number that shows you, not random figure. This is really important parameter to select the accumulator. If you're increasing or decreasing the maximum pressure, then how it affects to your accumulator, let's see. So let's say we are making the maximum operating pressure is 2500 psi, and when I'm entering this, you can see the actual volume coming out from accumulator is reduced drastically from 3 to 1.87 GPM. And if I'm increasing my maximum pressure 3 from 2500 to, let's say, 3500 psi, then I'm having more volume than the previous case. So you have to consider, or you have to check what is your maximum operating pressure in the cylinder, and from there you can select the correct size of accumulator. In my case, my maximum operating pressure is 3000 psi, because I'm using I'm using that manifold having a maximum pressure is 3000 psi, so this figure is constant, but then I have to increase my uh, total volume of actuator, or sorry, not the actuator, accumulator, from 15 to 20, or next higher size. So next higher size, let's say it's 20 gallon, then 20 gallon is the perfect fit for my HPU, because that satisfied the delta V. You can use the same calculation by using or by having different values with you. Let's say you don't know the total size of accumulator, but you know the delta V, that's the difference of volume that you need to enter in your actuator, and we know that detail is like 3.7 exactly. So you can use the same thing. This is one way of calculating the accumulator, and this is the second way of calculating the accumulator. Everything is same. You have to enter the maximum pressure, again is a 3000 psi, and delta V. In this case, if you know the delta V, so we know the delta V, and delta V is 3.7 gallon. So when I'm entering 3.7, it gives me V0 value. So V0 is 18.36. That means I need accumulator having a total volume of 18.36 gallon. In this 18.36 gallon, the nitrogen volume is 11.08, and the oil volume will be 7.34. So this is really important thing. The oil volume inside the accumulator will be 7.34 only, in total volume of 18.36, and the remaining volume will covered by nitrogen. So make sure you have enough volume of nitrogen in your nitrogen bottles. You can check, and you can have a nitrogen bottle constantly attached with your accumulator if it's a really big system, let's say a hydro turbine, or any power plant when you often face the emergency conditions. So you should have that backup volume available with you to operate your accumulator perfectly. I hope you find this video good, and you understand almost everything in this spreadsheet. And I have many other spreadsheet ready with me: how to size the heater, cooler, how to size the pipes, and how to select your hose size correctly, what is the pressure drop in the manifold and valves, and how to select the servo valve as well. So please keep watching my video, please subscribe my channel, and please tell your friends as well to subscribe it, to encourage me to create more videos like this. And again, the same way you can download this spreadsheet from the link available in description section. I hope you like it, and stay safe, and ask me any question if you have in comment section, and I'll be available to help you guys to select your hydraulic power unit. Okay, take care. Bye bye.